Hello, in this lecture we'll find out the area of the orange shape. In the drawing we have square ABCD. One side of square ABCD equals to 10 units. Inside this square we have two semicircles, semicircle APD and semicircle CPD, and they intersect with each other, and they create the blue lens. And we also have the quarter circle that intersects with this semicircle, and in this way the big lens, this big lens was created, and our mission is to find out the orange shape DPQ, that is the orange shape. So it is actually it is very easy to see from the drawing that the orange shape equals to the big lens minus the blue lens. Again, the big lens, this big lens minus the area of the blue lens equals to the area of the orange shape. Okay, so actually you can write it down. The orange shape, that is actually shape DPQ, the area of the orange shape equals to the area of the big lens minus the area of the blue lens. And repeat again, the area that we are looking for is the area of the orange shape, and the area of the orange shape equals to the area of the big lens minus the area of the blue lens. Okay, the area of the big lens minus the area of the blue lens will give us the area of the orange shape DPQ. Okay, so in the first method we will create general formula of the area of any lens, and then we'll find the area of the big lens according to the general formula, and then we'll find the area of the blue lens according to the new formula, and we'll subtract the area of the blue lens from the area of the big lens. In this way we'll get the area of the orange shape DPQ. Okay, but first of all I will explain a new theorem. What is the area of the green sector? The area of this green sector equals to pi r squared, that is, r is the radius of this circle, so pi r squared is the area of the circle times the ratio between angle theta and 2 pi, that is actually 360 degrees, that is to say 2 pi radians is 360 degrees. In terms of degrees, it is 360 degrees. So when we divide theta by 2 pi, it will give us the how many percentage of this circle this green sector occupies, and then we will multiply the area of the circle by the percentage that this sector occupies out of the area of all the circle. It will give us exactly the area of this sector. Okay, again, theta over 2 pi gives us the amount of percentage that this sector occupies out of the whole circle, and then when we multiply the area of the circle by this percentage, it will give us exactly the area of this green sector. So it is theta over 2 pi times pi r squared gives us the area of this sector. Okay, and the next term is the area of this circular segment AB. What is the area of circular segment AB? From the drawings, it's very easy to see that the area of circular segment AB, the green shape, equals to the area of sector AOB minus the area of triangle AOB. Again, the area of sector AOB minus the area of triangle AOB will give us exactly the area of sector circular segment AB. Okay, again, the area of sector AOB minus the area of triangle AOB will give us exactly the area of circular segment AB, that is the green shape. Okay, now we start to solve the question. So here we have two semicircles that are perpendicular to each other. The intersection of those two semicircles creates a common area. This is the common area of those two semicircles, and this common area, it is defined as the length, and we will find out the area of this length. And because of the fact that this length could be any length, we'll use this general formula in order to find out the area of the blue lens and also the area of the big lens, because this formula is good for any lens, and especially for those two hour lenses. Okay, so first of all, we will define the vertex here as point M, and here we will define the radius of this semicircle as A. We define the radius of this semicircle as B. And we'll define the point, the center of this semicircle is point O. We define this point as point N. And we define the center of this semicircle as point L. and here point N is the point of tendency of tangent Ln with this semicircle. O is the center of this semicircle, N is the point on the semicircle itself. That is to say, this is exactly the definition of a radius. So ON is the radius of this semicircle that is equal to A units according to our definition. Here point L is the center of this semicircle, point N is the point on the semicircle itself, therefore Ln is the radius of this semicircle that is equal to B according to our definition. Point M is the point of tendency of tangent Ln with this semicircle. So here point M is the point of tendency. So here we have the radius OM that is drawn to the point of tendency, that is to say it is drawn to point M, that is the point of tendency of tangent Ln with this semicircle. And whenever you have a radius that is drawn to the point of tendency, then tangent Lm will be perpendicular to the radius MO. So if Lm is perpendicular to MO, it means that this angle equals to 90 degrees. Likewise, we have the radius ON that is equal to A. It is drawn to the point of tendency. That is to say, it is drawn to point N, that is the point of tendency of tangent Ln with this semicircle. And whenever you have a radius that is drawn to the point of tendency, then tangent Ln, this tangent Ln will be perpendicular to the radius NO. So if Ln is perpendicular to NO, it means that angle ONN, this angle, equals to 90 degrees. Okay? In the next step, we'll join points M and N together by a straight line. And we'll join points L and O by a straight line. By joining points M and N by a straight line, we divided this length into two identical parts. We have the upper circular segment MN and we have the lower circular segment MN. So in the first step, we'll find out there are actually those two circular segments are not identical. Why? Because here the radii of those two semicircles are not equal to each other. The radius of this semicircle is A, and the radius of this semicircle is B, and A is not equal to B, so those two circular segments are not identical, and therefore we'll find out the area of each circular segment. So we'll start with the area of this great circular segment, then we'll find out the area of the lower circular segment. So what is the area of the upper circular segment, the area of the green circular segment, the area of the green circular segment, MN, it will be equal to the area of sector MON, the area of this sector MON, so this is sector MON, minus the area of triangle MON, minus the area of triangle MON, this triangle. So this is triangle MON. Okay, the area of sector MON minus the area of triangle MON will give us the area of the green circular segment MN. So in the next step, after we finish to find out the area of this circular segment, we'll find out the area of the lower circular segment. We will add the two areas together, and this will be the area of this lens. This lens could be any lens, so we'll use the new formula that we will find in order to find out the area of the blue lens, this blue lens, and the area of the big lens. Okay? So first of all, we find out the area of circular segment MN. It is equal to the area of sector MON. In order to find out the area of sector MON, we have to find the area between its legs that are MO and ON. So we have to find out the area of angle MON, the area of this angle. Okay. So what is the area of this angle MON? Actually, those two triangles can go into each other according to side rule. That is to say, triangle LON can go into triangle LON. Why they can go into each other? First of all, those two sides are both equal to A, therefore they are equal to each other. Those two sides, they are both equal to B, therefore they are equal to each other. And finally, LO is the common side that belongs to both triangles. So this side is equals to itself. So those two triangles can go into each other according to side rule. And if we define angle LOM as theta, then because of the fact that those two triangles can go into each other, that is to say, those two angles are equal to each other. So if this angle equal to theta, then this angle must be also equal to theta because they are equal to each other. So actually found out that the area between the legs of sector MON, the angle between the legs of sector MON is theta plus theta, that is 2 theta. Okay? So here, the angle between the two legs of sector MON, it is equal actually to 2 theta. Okay? And the area of sector MON, it is equal to the angle between his legs is 2 theta over 2 pi, that is 2 pi radians is 360 degrees. This ratio gives us how many percentage of the circle this sector occupies. Then we multiply this percentage by the area of the whole circle, that is pi r square, but r equals to a, therefore it is pi a square. And in this way we get the area of this sector, sector MON. Okay? So here we have theta in the numerator and theta in the denominator. So theta will get cancelled. Pi, we have pi in the numerator and pi in the denominator, so pi will get cancelled. Here we have 2 in the numerator and 2 in the denominator, so 2 also will get cancelled. In conclusion, the area of sector MON, this sector, equals to theta a square. Theta a square. So we finished with this circular segment. Actually, in the first method, you don't have to calculate the area of the triangle. We will actually combine the two triangles together, and we'll find out the total area. And in this way, we will save the time, and we don't have to calculate the area of each triangle. We will have the area of the two triangles together, and we don't have to calculate the area of each triangle. So what is the area of the second circular segment? Actually, the area of the lower circular segment MN the area of the lower circular segment, the orange circular segment MN, the orange circular segment MN will be equal to the area of sector NLN, this sector, This is sector MLN. Minus the area of triangle MLN. Minus the area of this triangle, triangle MNL. This is triangle MLN. If you subtract the area of triangle MLN from the area of sector MLN, you will get exactly the lower circular segment MN. Okay? In order to find out the area of sector MLN, we have to find out the angle between his legs, that is this angle MLN. So what is the value of angle MLN? This angle, so here we know that in the right triangle OML, this angle equals to theta. This angle equals to 90 degrees or pi over 2 in terms of radians. So this angle must be equal to pi over 2 minus theta. In order to complete the sum of the angles in the right triangle OML 280 degrees, this angle must be equal to pi over 2 minus theta. Those two triangles can go into each other, therefore those two angles must be equal to each other. So this angle must be also equal to pi over 2 minus theta. Okay? So the size of angle MLN equals to the sum of those two angles. So it is equal to angle, this angle that is equal to pi over 2 minus theta, plus this angle that is also equal to pi over 2 minus theta. So here pi over 2 plus pi over 2 is pi, and minus theta plus minus theta is minus 2 theta. So in conclusion, we found out that the size of this angle MLN, equals to pi minus 2 theta. So the angle between the legs of sector MLN, it is equal to pi minus 2 theta. Here it is pi minus 2 theta. So the area of sector MLN equals to the area of the circle, that is pi r squared, and r equals to b, that is, so if r equals to b, so the area of the circle is pi b squared. So it is the area of the circle times the amount of percentage, the amount of percents that this sector occupy out of the whole circle, and the amount of percentage that this sector occupies out of the whole circle will be equal to the size of the angle that is between his legs, that is actually theta minus 2 pi minus 2 theta, over 2 pi, that is the angle of 360 degrees. Okay, so the angle between the legs of the sector over 360 degrees or 2 theta or 2 pi will give us the amount of percentage of the how many percentage out of the whole circle this sector occupies. If the area of the circle is pi b squared, when we multiply the area of the circle that is pi b squared times the amount of percentage that this sector occupy, it will give us exactly the area of the sector. Okay, so we found out the area of this sector. Here we have pi in the numerator and pi in the denominator, so pi will get cancelled. In the next step, we'll open the brackets here and we'll get that pi b squared over 2 minus 2 theta times b squared over 2. Here we have 2 in the numerator, 2 in the denominator, so 2 will get cancelled. And so the area of sector MLN, it is equal to, in total, pi b squared over 2 minus theta times b squared. That is the area of sector MLN, but actually we want to find out the area of this lens, and the area of this lens equals to the area of the green circular segment plus the area of the orange circular segment. Okay, and the area of the green circular segment equals to the area of sector MON minus the area of triangle MON plus the area of sector MN, the lower circular segment, that is equal to the area of sector MLN minus the area of triangle MLN. So in conclusion, we can write down that the area of the lens itself, it is equal to the sum of the areas of the two sectors minus the sum of the areas of the two triangles. Okay? I write it down. The area of the lens equals to the area of the upper circular segment, that is the area of sector MON minus the area of triangle MON plus the lower circular segment that is equal to the area of the sector MLN minus the area of triangle MLN. Okay, so it is actually equals to the sum of the areas of the two sectors, that is equals to the area of the first sector is theta A square plus the area of the second sector is pi B square over 2 minus theta times B square minus the area of the two triangles. So we'll actually join together the two triangles and so the first triangle is triangle MON. And the second triangle is triangle MLN. We actually join the two triangles together. This angle equals to 90 degrees. And this angle also equals to 90 degrees. In the next step, we'll join points O and L together by a straight line. So we actually created here two right triangles, triangle MOL and triangle ONL. And the sum of the areas of those two right triangles will be equal to the sum of the areas of the two original triangles. Okay? So the area of the green right triangle is the base times the height over 2, that is A times B over 2, plus the area of the orange right triangle, it is the base is A times the height to the base is B over 2, is also A times B over 2. So A times B over 2 plus A times B over 2 equals to 2 times A times B over 2. We have 2 in the numerator and 2 in the denominator, so 2 will get cancelled. So finally we found out that the area of the two triangles it is equal to A times B. Okay, so here we have to subtract the area of the two triangles. In this way, we find out the area of this length that could be any length. So the area of this length that could be any length, it is equals to theta times A squared plus pi B squared over 2 minus theta times B squared. We have to subtract from the sum of the areas of the two sectors the sum of the areas of the two triangles, that is AB. So we have to subtract from this sum AB, so it is minus AB. Okay. So here we take theta as a common factor, and we get that the area of the blue lens and the area of the lens that could be any lens is equal to, so we took theta as a common factor, inside the brackets we have A squared minus B squared plus pi B squared over 2 minus AB. So this is the area of the length that could be any length. In the next step, we'll find out the value of theta. So I'll copy the right triangle OMN here, and we find out the value of theta. So we'll focus on this right triangle MOL. Here it is very easy to see from the drawing that tangent theta equals to ML over MO. MN equals to B and MO equals to A. So in conclusion, we found out that tangent theta equals to B over A. Actually, we want to find out the value of theta itself. Therefore, we will operate the opposite function of tangent on the result. And in this way we find out the value of theta. So here theta will be equal to tangents minus 1, that is the opposite function of tangents of B over A. So we found out the value of theta. Okay. Now we'll substitute theta by tangents minus 1 of b over a. And we'll get that the area of a length that could be any length will be equal to a square minus b square times theta, and theta is tangents minus 1 of b over a plus pi b square over 2 minus ab. We actually found out the formula for the area of any length. Now we'll use this formula in order to find out the area of the blue lens and the area of the big lens. So here, first of all, we find out the area of the big lens. Actually, the area of the big lens is created by intersection of the quarter circle with this semicircle. Okay, so we need the radius of the quarter circle. The radius of the quarter circle equals to 10. So here a equals to 10. Units, and the radius of the semicircle. We know that the diameter of this semicircle is equal to 10 units, therefore the radius will be equal to half of it. That is to say, the radius of the semicircle will be equal to 10 over 2, that is 5. So b equals to 5 units. B is the radius of the semicircle, that is equal to 5 units. Now we'll put the values of a and b in this general formula and find out the area of the big lens. So here a equals to 10, so a square is 10 square minus b square. B is 5, so b square is 5 square times tangents minus 1 of b over a. b is 5, a is 10, so b over a is 1/2, that is 0.5. Plus pi b square over 2. b is 5, so b square is 5 square, that is 25. So it is actually 25 pi over 2 minus AB. A is 10, B is 5, so it is AB is 10 times 5 in negative sign. So it is minus 10 times 5. So the area of the big lens equals to 10 square minus 5 square. 10 square is 100, minus 5 square is 25, and 100 minus 25 is 75, times tangents minus 1 of 0.5 plus 25 over 2 is 12.5, so this expression in total equals to 12.5 0.5 pi minus 10 times 5 is minus 50. So in conclusion, we found out that the area of the big lens equals to 75 times 10 raised minus 1 of 0.5 plus 12.5 pi minus 50. Okay? In the next step, we'll find out the area of the blue lens. The area of the blue lens was created, by the intersections of the two semicircles with each other. So we have to find out the radius of each semicircle, and we have already found out that the radius of each semicircle it is equal to 5 units. So here A equals to 5 and B also equals to 5. So we put the values of A and B inside the formula for the area of a lens, and we find out the area of the blue lens. So the area of this blue lens will be equal to A square minus B square. A is 5, so A square is 5 square minus B square. B is 5, so B square is 5 square times tangents minus 1 of B over A. B is 5 and A is 5, so it is 5 over 5, that is 1. So this expression equals to 0 because 5 square minus 5 square is 0. Plus pi, B equals to 5, so B square is 5 square. So it is 25 over 2 minus AB. A is 5, B is 5, so AB is 5 times 5, that is 25. So in conclusion, we found out that the area of the blue lens equals to 25 over 2 is 12.5. So in conclusion, in total this expression equals to 12.5 pi. So the area of the blue lens equals to 12.5 pi minus 25. Okay. So now we will subtract from this big lens, we subtract the area of the blue lens, and we get the area of the orange shape. Again, the area of the orange shape it is equal to the area of the big lens, that is actually the area of the big lens, it is actually equals to 75 times tangents minus 1 of 0.5 plus 12.5 pi minus 50. This is the area of the big lens. Minus the area of the blue lens, and the area of the blue lens is equal to 12.5 pi minus 25. Okay. So here we'll open the brackets and we get that the area of the orange shape equals to 75 times tangents minus 1 of 0.5 plus 12.5 pi minus 50. We'll open the bracket here, so it will be here minus 12.5 pi minus and minus is plus, so it is minus 25 is plus 25. So actually found out the area of the orange shape. Here we have 12.5 pi minus 12.5 pi is 0, and 25 minus 50 is minus 25. So in conclusion, I found out that the area of the orange shape equals to 75 times tangents minus 1 of 0.5 minus 25. Okay. So the area of the orange shape equals to 75 times tangents 1 of 0.5 minus 25, and the value of tangents minus 1 of 0.5, it is about 0.46. We have to multiply 0.46 by 75. It is actually equals to 34.77 minus 25. It is equal to 9.77. Okay, so the area of the orange shape equals to 9.77 square units. We finished in the first method. In the next step, I'll present to you how to find out the area of this orange shape according to the second method. Okay. In the second method, we will not create general formula to find out the area of any length, but we directly find out the area of this blue length. We'll find out the area directly. We'll find out directly the area of the big length. We'll find out the area of the blue length. We subtract the area of the blue length from the area of the big length, and in this way we get the area of this orange shape DPQ. Okay, so we start with the area. In the first step, we find out the area of the blue shape. Okay. So here we have the blue shape was created by the intersection of the two semicircles with each other. So we actually created here, in the first method, we have all the data that we created. We can use it for the two semicircles that intersect with each other, and they create the blue shape. So this point equals to M, this point equals to O. This the radius here is 90 degrees. The radius here was also 90 degrees. You know that the radius of each semicircle equals to 5 units. We divide the blue length into two parts. Each part is the circular segment. We'll find out the area of the upper circular segment MN, then we will multiply it by 2, and in this way we'll find out the area of the blue length, because the two shapes, the two parts, those two parts are identical, therefore they have the same area. So what is the area of the green circular segment? The area of the green circular segment equals to the area of sector MON the area of this sector. This is sector MON. Minus the area of triangle MON. And the area of sector MON, actually sector MON is a quarter circle, and the area of any quarter circle equals to the area of the circle over 4. And the area of the circle with radius 5 is pi 5 squared. That is 25 pi. And if we divide it by 4, we get the area of the quarter circle. So it is 25 pi over 4 minus the area of this circle, that is equals to 5 times 5 times over 2. Okay, so in conclusion, we found out that the area of the upper circular segment of the blue lens equals to 25 pi over 4 minus 5 times 5 over 2. Now we will multiply the area of this circular segment by 2, and in this way we get the area of the blue lens. So the area of the blue lens will be equal to 2 times 25 pi over 4 minus 25 pi over 2 times 2. In conclusion, we found out that the area of the blue lens equals to, here we have 25 pi. We divide both the numerator and the denominator by 2, and we get that 2 over 2 is 1 and 4 over 2 is 2. So in conclusion, it is 25 pi over 2 minus, we have 2 in the numerator, 2 in the denominator, so 2 will get cancelled. So it is minus 25. But 25 over 2 is 12.5. So the area of the blue lens equals to 12.5 pi minus 25. Okay. I'll repeat again. The area of this blue lens, it is equals to 12.5 pi minus 25 square units. We finished with the blue lens. In the next step, we'll find out the area of the big lens. So here it is equal to 10. So the blue lens is created by the intersection of the quarter circle with the semicircle. So here we join the two centers together. So this is the radius of the semicircle, that is 5 units. This is also the radius. Here we have the radius that is drawn to the point of tendency, that is to say it is drawn to point N, that is the point of tendency of tangent MN with this quarter circle. Therefore, whenever I have a radius that is drawn to the point of tendency, then tangent MN will be perpendicular to the radius NO. So if MN is perpendicular to NO, it means that this angle equals to 90 degrees. Okay. So here we also have the radius OL that is drawn to the point of tendency, that is to say it is drawn to point L, that is the point of tendency of tangent ML with this quarter circle. Whenever I have a radius that is drawn to the point of tendency, then tangent ML will be perpendicular to the radius LO. So if ML is perpendicular to LO, it means that this angle equals to 90 degrees. So actually, those two triangles can go into each other according to side rule. Here, those two sides are equal, they are both equal to 10, therefore they are equal to each other. Those two sides, they are both equal to 5, therefore they are equal to each other. And we have also a common side OM that is belongs to those triangles. So both, that is a common side that belongs to both triangles. So those two triangles can go into each other according to side rule. Therefore, we conclude from it that those two angles are equal to each other according to the rule that corresponding angles in congruent triangles are equal to each other. So if this angle equals to theta, then this angle must be equal to theta because those two angles are equal to each other. So we will divide the big lens into two parts and we will find out the area of each part, and then we will add the two areas together. In this way we find out the area of the big lens. Okay. So first of all we find out the area of the upper circular segment, LN. The area of the upper circular segment LN the area of the upper circular segment LN, this segment, will be equal to the area of sector LOM minus the area of triangle LOM. So it will be equal to the area of sector LOM this is sector LON. The angle between its legs is theta plus theta is 2 theta. Each leg equals to 10 units in its length minus the area of triangle LON. I'll repeat again. The area of circular segment LN, that is the upper side of the big lens, equals to the area of sector LON minus the area of triangle LON. The area of sector LON, it will be equal to the area of the circle, that is pi r squared, and r equals to 10, so it is pi times 10 squared times the amount of percentage of the, how many percentage the sector occupies out of the whole circle. So it is the size of the angle between his legs, that is 2 theta, over 2 pi, that is actually equals to 360 degrees. Okay? So here we have 2 in the numerator and 2 in the denominator, so 2 will get cancelled. We have pi in the numerator and pi in the denominator, so pi also will get cancelled. So in conclusion, the area of sector LON equals to 10 squared is 100, so it is 100 theta minus the area of triangle LON. The area of triangle LON, it will be equal to the multiplication of the two sides here together, that is 10 times 10 times sinus the angle between the two legs, the angle between the two sides here, that's sinus 2 theta over 2. Okay? So in conclusion, we found out that the area of circular segment N equals to 100 times theta times is equal to 100 times theta is 100 times theta minus 10 times 10 is 100, and 100 over 2 is 50, so it is 50 times sinus 2 theta. So in the next step we will find out the value of theta and the value of sinus 2 theta. Okay. So I copy the right triangle LOM, and we will derive from the right triangle LOM the value of theta and also the value of sinus 2 theta. So we have triangle OLM actually. Triangle OLM is a right triangle with one angle that is equal to theta. That is the triangle that we are looking for. So here, in the right triangle, triangle LOM, tangent theta equals to LM over LO. And LM equals to 5 and LO equals to 10, so 5 over 10 is 1 half, that is 0.5. So in conclusion, we found out the tangent theta equals to 0.5 but we are looking for theta itself, so we will operate the opposite function of tangents in the result, and in this way we get theta. So theta will be equal to the opposite function of tangents, that is tangents minus 1. We will operate it on the result, that is 0.5, and in this way we get the value of theta itself. Okay, so we found out the value of theta. In the next step we'll find out the value of sinus 2 theta that we have here. We have in the formula here sinus 2 theta. We have theta, so we already found out the value of theta. Now we'll find out the value of sinus theta. That is part of the equation of the area of the upper circular segment. We have the trigonometric identity that sinus 2 theta equals to 2 sine theta cosine theta I copy the right triangle LOM to again here. This is the right triangle LOM. This is angle theta. So here actually sinus theta. So first of all we find out the value of the hypotenuse ON in the right triangle LOM. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars, that is to say OM squared equals to LO squared, that is 10 squared is 100, plus LM squared is 5 squared, that is 25. So in conclusion, we found out that 100 plus 25 is 125. So OM squared equals to 125. OM squared equals to 125. We'll take a root out of this equation, and we found out that OM equals to the square root of 125, and 125 is equals to 25 times 5, so we substitute 125 by 25 times 5. Here we'll take a root out of this equation, and we find out that the square root of 25 is 5, so inside the root we left only the 5. So in conclusion, the hypotenuse OM equals to 5 times square root of 5. So here we get that sinus 2 theta equals to 2 times sinus theta. According to this triangle, this right triangle, sinus theta equals to LM over MO. LM is 5 and MO is 5 times square root of 5. So in conclusion, sinus theta equals to 5 over 5 times square root of 5 times cosine theta, and cosine theta equals to, according to this right triangle LOM, cosine theta equals to LO over OM. So LO is 10 and OM is 5 times square root of 5. So in conclusion, sinus 2 theta equals to this expression. Here we have 5 in the numerator and 5 in the denominator, so 5 will get cancelled. And we have here in the numerator 2 times 10 over 5, square root of 5 times square root of 5 is 5. So here 10 over 5 is 2. So we have here 2 times 2 over 5. 2 times 2 is 4 over 5. So in conclusion, we found out that sinus 2 theta equals to 4/5. Okay. Actually, we found out that theta equals to tangents minus 1 of 0.5 and sinus 2 theta is equal to 4/5 and we actually found out that the area of the upper circular segment LN it is equal to 100 times theta minus 50 times sinus 2 theta. In the next step, we substitute theta by tangents minus 1 of 0.5, and we substitute sinus 2 theta by 4/5, and we get that the area of the upper circular segment of the big lens, the big lens, it is actually equals to 100 times theta, and theta is tangents minus 1 of 0.5 plus 50 minus 50 times sinus 2 theta, and we already found out that sinus 2 theta equals to 4/5. So in conclusion, we found out that the area of the upper circular segment of the big lens, it is equals to 100 times tangents minus 1 of 0.5 minus 50 over 5 is 10, and 10 times 4 is 40, so it is minus 40. Again, in conclusion, we found out that the area of the upper circular segment Ln, it is equal to 100 times tangents minus 1 of 0.5 minus 40. Okay, so we finished with the upper size of the big lens. Now we found out that the area of the lower circular segment of the big lens. So here we just right now found out the area of the upper circular segment. Now we'll find out the area of the lower circular segment. This circular segment Ln, the lower circular segment Ln. Okay. So here this is 10. This angle equals to 90 degrees. This angle also equals to 90 degrees. Angle ONM equals to 90 degrees. We already found out that those two angles are both equal to theta. So what is the value of angle LMN? In triangle LMO, this angle equals to theta, this angle equals to pi over 2, so this angle must be equal to pi over 2 minus theta. And this angle equals to theta, this angle equals to 90 degrees, so this angle must be equal to pi over 2 minus theta. So in total, the size of angle LMN, it will be equal to pi over 2 minus the sum of those two angles, that is actually pi over 2 minus theta plus pi over 2 minus theta. Pi over theta, pi over 2 plus pi over 2 is pi, and minus theta plus minus theta is minus 2 theta. So there at the end, the size of angle LMN, it is equals to pi minus 2 theta. Okay. Our mission is to find out the area of the lower circular segment of the big lens. The area of this green shape that is actually defined as the lower circular segment of the big lens. So the area of the lower circular segment this lower circular segment Ln it will be equal to the area of sector LMN, this sector, the area of sector LMN this is sector LMN, angle LMN, this angle equals to pi minus 2 theta, so it is sector LMN minus triangle LMN, minus the area of triangle LMN. This is triangle LMN, angle LMN equals to pi minus 2 theta. So here the area of sector LMN equals to the area of the circle with radius 5 is pi r squared, so r is 5, so it is pi times 5 squared times the percentage, how many percent this sector occupy out of the whole circles. This is actually equals to the ratio between angle pi minus 2 theta over 2 pi, this is actually 2 pi radians, is 360 degrees in terms of degrees. So here we have pi in the numerator and pi in the denominator, so pi will get cancelled. Now we open the brackets and we get that the area of sector LMN equals to 25 pi over 2 this is actually pi 25 pi over 2 minus 2 theta over 2 times 25. So here we have theta in the numerator and 2 in the numerator and 2 in the denominator, so 2 will get cancelled. So in conclusion, the area of sector LMN equals to 25 over 2 is 12.5 pi minus 25 theta. Okay, and we have to subtract also from the area of sector element the area of triangle element, and the area of triangle LMN equals to the multiplication of the two sides LM and MN, that is LM equals to 5 and MN equals to 5, so it is 5 times 5 times sinus the angle between the two legs, the two sides is pi minus 2 theta, all divided by 2. So here we have the, in conclusion, the area of the lower circular segment of the big lens is 12.5 pi minus 25 times theta here 5 times 5 is 25 over 2 sinus pi minus 2 theta equals to sinus 2 theta, and we have already found out that sinus 2 theta equals to 4/5. So in conclusion, the area of the lower circular segment of the big lens the lower circular segment of the big lens, it is circular segment LN, it is equal to 12.5 pi minus 25 theta minus 25 over 2 and times sinus theta, but sinus theta equals to 4/5, so we substitute sinus theta by 4/5. So in conclusion, we found out that the area of the lower circular segment LN of the big lens equals to 12.5 pi minus 25 theta, and we have already found out that theta equals to tangents minus 1 of 0.5, so we substitute theta by tangents minus 1 of 0.5, and here we have 25 over 5 is 5, and 5 times 4 is 20, and 20 over 2 is 10, so it is minus 10. So in conclusion, we found out that the area of the lower circular segment of the big lens equals to 25 pi, 12.5 pi minus 25 times tangents minus 1 of 0.5 minus 10. And we have already found out also the upper side of the area of the upper circular segment of the big lens. We actually found out that the area of the upper circular segment of the big lens is actually equals to 100 times tangents minus 1 of 0.5 minus 40. Now we have to add the two areas together in order to get the area of the big lens. So we'll add the two areas together, the upper circular segment plus the lower circular segment equals to the area of the big lens. So the area of the big lens, will be equal to the area of the upper circular segment, that is actually 100 times tangents minus 1 of 0.5 minus 40 plus the area of the upper plus the area of the lower circular segment of the big lens, that is 12.5 pi minus 25 tangents minus 1 of 0.5 minus 10. Okay, so in conclusion, we found out that the area of the big lens equals to, we have here 100 times tangents minus 1 of 0.5 minus 25 tangents minus 1 of 0.5, it is equals to 75 times tangents minus 1 of 0.5. We have here minus 40 plus minus 10 is minus 50. And we have here also 12.5 pi plus 12.5 pi. This is the area of the big lens. And we have already found out that the area of the blue lens equals to 12.5 pi minus 25. Now, from there, with the area of the big lens minus the area of the blue lens equals to the area of the orange shape. Again, here, the area of the big lens minus the area of the blue lens equals exactly to the area of the orange shape. So the area of the orange shape equals to the area of the big lens minus the area of the blue lens. Okay? So we found out actually that the area of the orange shape equals to the area of the big lens, and the area of the big lens equals to 75 minus 75 tangents minus 1 of 0.5 minus 50 plus 12.5 pi. This is the area of the big lens, and we have to subtract from it the area of the blue lens. So it is minus the area of the blue lens, and the area of the blue lens equals to 12.5 pi minus 25. Okay, we open the brackets here and we'll get that the area of the orange shape equals to 75 times tangents minus 1 of 0.5 minus 50 plus 12.5 pi. We open the brackets here and we get minus 12.5 pi, and here we have minus and minus is plus 25. So we found out the area of the orange shape is equal to this expression. Here we have 12.5 pi minus 12.5 pi is 0, so those two expressions will get cancelled. And we have 25 minus 50 is minus 25. So in conclusion, the area of the orange shape equals to 75 times tangents minus 1 of 0.5 minus 25. This is the area of the orange shape. Okay, and we know that tangents minus 1 of 0.5, it is equal to 0.46, and we'll multiply 0.46 by 75, and we find out that the area of the orange shape equals to 75 times 0.46 is 34.77 minus 25, 34.77 minus 25 equals to 9.77 square units. Okay, so we found out the area of the orange shape. The area of this orange shape equals to 9.77 square units. We finish with the second method. In the next step, I will summarize the lecture. Okay. So, in the first method, we actually created general formula to find out the area of any lens. Then we calculated, according to the formula that we created, the area of the big lens. Then we calculated the area of the blue lens, and we subtract the area of the blue lens from the area of the blue lens from the area of the big lens, and this way we got the area of the orange shape. Okay. So in the drawing we have this square ABCD, so we have square ABCD. Each side of square ABCD equals to 10 units. Inside square ABCD we have two semicircles that intersect with each other, and this way they create this blue lens. And we have also the quarter circle A, B, Q, D, this quarter circle that intersects with this semicircle, and in this way the big lens was created. And our mission is to find out the area of the orange shape that is actually equals to the area of the big lens minus the area of the blue lens. Okay, so in the first method we created general formula to find out the area of any lens, and then we use the general formula for the area of any lens in order to find out the area of this big lens. Then we found out the area of this blue lens, and we subtracted the two areas from each other, and this way we got the area of the orange shape. Okay, so I repeat again that the idea is to create a formula, general formula for the area of any lens, and then we use the new formula, the general formula, in order to find out the area of the big lens. We find out the area, according to the new formula, we'll find out the area of the blue lens also. We'll subtract the two areas from each other, and this way we get the area of the blue, this orange shape QPD. Okay. Anyway, in order to find out the area of this blue and of this orange shape, we must subtract from the area of the big lens the area of the blue lens, and this way we get the area of the orange shape. So first of all, I presented to you two new terms. What is the area of this green sector? The area of this green sector equals to the area of this circle that is pi r squared, because the radius of this circle is r. times the ratio between angle theta to 360 degrees, or to 2 pi, that is equals to 360 degrees. That ratio will give us the amount of percentage, the amount of percent that the sector occupies, from how many percentage this sector occupies out of the whole circle. And then when we multiply the area of this circle by the amount of percentage that this sector occupies, we'll get the area of the green sector. Again, theta over 2 pi times pi r squared, that is the area of this circle, will give us the area of this green sector. And then I presented to you the formula for the area of the green circular segment AB. So the area of circular segment AB equals to the area of sector, this sector AOB. This is the area of sector AOB minus the area of triangle AOB. Again, the area of sector AOB minus the area of triangle AOB will give us exactly the area of circular segment AB. Okay? So, now our mission is to find general formula for the area of any length, and then we'll use the general formula in order to find out the area of the blue lens and the area of the big lens also. And then we'll subtract the area of the blue lens from the area of the big lens. In this way we'll get the area of the whole shape QPD. Okay? So here we took two semicircles that are perpendicular to each other. The radii of the two semicircles are not equal to each other. The radius of the first semicircle is A, while the radius of this semicircle is B. Actually, in the intersection point of those two semicircles, they create common area. This common area is defined as a length, and our mission was to find out the area of this length. Okay, so here, first of all, here we define the center of this semicircle as point O, we define the center of this semicircle as point L, the radius of this semicircle is A, while the radius of this semicircle is B. And here we have here O is the center of the semicircle, M is the point on the semicircle itself, therefore OM is the radius of this semicircle, that is A. So here the radius OM, it is known to the point of tendency, that is to say it is known to point M, that is the point of tendency of tangent LM with this semicircle. And whenever you have a radius that is known to the point of tendency, then tangent LM will be perpendicular to the radius MO. So if LM is perpendicular to MO, it means that this angle equals 90 degrees. Likewise, we have here the radius ON, that is known to the point of tendency, that is to say it is known to point N, that is the point of tendency of tangent LN with this semicircle. And whenever you have a radius that is known to the point of tendency, then tangent LN will be perpendicular to the radius NO. So if LN is perpendicular to NO, it means if LN is perpendicular to NO, it means that this angle equals 90 degrees. Then we join points M and N together by a straight line. By joining points M and N together by a straight line, we actually divided the length into two parts. And we find out the area of each part, then we'll add the two areas together, and in this way we find out the area of this length. Okay, so, and we also join points O and L together by a straight line. So here, first of all, we find out the area of circular segment MN, the green shape. What is the area of circular segment MN? The area of circular segment MN, the green shape, will be equal to the area of sector MON minus the area of triangle MON. Okay. I'll repeat again. First of all, as I already mentioned, the general idea how to solve this question, the area of this green shape equals to the area of the big length minus the area of the small length. Again, the area of this orange shape DPQ will be equal to the area of the big length minus the area of the blue lens. The area of the big lens minus the area of the blue lens give us exactly the area of shape DQP, that is the orange shape. Okay. So, by this, according to this idea, we use this idea in both methods. In the first method, we find out general formula to find out the area of any length, and then we'll put in this general formula the data of the big length. In this way we'll find out the area of the big length, and we'll use the same formula in order to find out the area of the blue length, and then we'll subtract the two areas from each other. In this way we get the area of the orange shape, QPD. Now our mission is to find out the area of the blue lens. The area of the blue lens consists of two circular segments. In the first step, we find out the area of the upper circular segment, this, and then we find out the area of the lower circular segment. We'll add them together. In this way, we find out the area of the blue lens. Okay, so what is the area of this green circular segment? The area of this green circular segment is equal to the area of sector MON, this sector, minus the area of triangle MON. So here, in order to find out the area of sector MON, we have to find out the size of angle MON, that is the angle between his legs. Okay? How we can find out the value of angle MON? The value of this angle MON in order to find out the value of angle MON, first of all, we know that those two triangles can go into each other according to side rule. If here those two sides are both equal to A, therefore they are equal to each other. Those two sides are both equal to B, therefore they are equal to each other, and side LO is the common side that belongs to both triangles. Therefore those two triangles can go into each other according to side rule. From the fact that those two triangles can go into each other, we conclude that those two angles also equal to each other according to the rule that corresponding angles in congruent triangles are equal to each other. So if this angle equals to theta, then this angle must be also equal to theta because those two angles are equal to each other. So we know that this angle equals to theta, this angle also equals to theta. So what is the size of angle MON? It is equal to the sum of those two angles. That is to say, theta plus theta is the size of angle MON. That is to say, angle MON equals to 2 theta. So we found out that angle MON equals to 2 theta. Then we found out the area of sector MON. It is equal to the area of the circle that contains the sector, that is pi r squared, but r equals to a, so it is pi a squared. The area of this circle is pi r squared, pi a squared, and we have to multiply it by the amount of percentage, the amount of percent that the sector occupies, how many percentage out of all the circle this sector occupies. It is the ratio between the angle between his legs over 360 degrees or 2 pi. Here we are using only radians and not degrees, therefore it is 2 pi, because 2 pi equals to 360 degrees, so it is 2 theta over 2 pi times pi a squared. We have pi in the numerator and pi in the denominator, so pi will get cancelled. We have 2 in the numerator and 2 in the denominator, so 2 also will get cancelled. So in conclusion, we found out that the area of sector MON equals to theta times a squared. Okay, actually we don't have to calculate the area of this triangle because we will find out the area of the two triangles, and we find out the sum of the areas of the two triangles, and for that reason we don't have to find out the area of this triangle at all. So we finished with the first circular segment, the upper circular segment. In the next step we'll find out the area of the lower circular segment. We will add the two circular segments, the areas of the two circular segments together, and this way we'll find out the area of this length that could be any length. Okay, the area of the lower circular segment, the orange lower circular segment, here it will be equal, the area of the orange circular segment will be equal to the area of sector NLM, this sector, minus the area of triangle NLM. I repeat again, the area of sector MN, the orange sector, this is the lower circular segment MN. It will be equal to the area of sector MLN minus the area of triangle MLN. So in order to find out the area of sector MLN, we have to find out the angle between his legs. We have to find out the size of angle MLN. So here, this angle equals to theta, this angle equals to pi over 2 or 90 degrees, so therefore this angle must be equal to pi over 2 minus theta. In order to complete the sum of the angles in this triangle to 180 degrees, this angle must be equal to pi over 2 minus theta. Okay, likewise here, this angle equals to theta, this angle equals to 90 degrees, therefore this angle must be equal to pi over theta minus 2. So the sum of those two angles will be the size of angle MLN. That is to say, the size of angle MLN will be equal to pi over 2 minus theta plus pi over 2 minus theta. pi over 2 plus pi over 2 is pi, and minus theta plus minus theta is minus 2 theta. So in conclusion, we found out that the size of angle MLN equals to pi minus 2 theta. So after we found out the size of the angle between the legs of sector M and N, now, this sector M and N, it is pi minus 2 theta. Now we can find out the area of this sector. The area of this sector equals to the area of the circle, that is pi r squared. R equals to b, so it is pi b squared times the ratio between the angle between the legs of the sector over 360 degrees. That will give us the amount, how many percentage out of all the circle this sector occupies. Okay, so the angle between his legs, that is pi minus 2 theta over 2 pi, that is equal to 360 degrees in terms of degrees. Okay, so here we have pi in the numerator and pi in the denominator, so pi will get cancelled. Then we open the brackets and we got here, it is pi b squared over 2 minus 2 theta b squared over 2. We have 2 in the numerator, 2 in the denominator, so 2 will get cancelled. In conclusion, we found out that the area of the lower circular segment of the lens is equal to pi b squared. It is not the area of the lower circular segment, but it is the area of the sector only. Okay, we'll deal with the triangles later. We have to subtract also the area of the triangle, but we'll deal with the triangle later. Okay. Okay, so here, in conclusion, the area of sector M and N equals to pi b squared over 2 minus theta b squared. Okay, so here, the area of the sector equals to the area of the lens equals to the area of sector M and MON minus the area of triangle MON plus the area of sector LMN minus the area of triangle MNN. Okay? So we have already found out that the sum of the areas of the two sectors equals to theta squared plus pi b squared over 2 minus theta b squared. Now we have to subtract from this expression the sum of the areas of the two triangles. So we combined the two triangles together, and in this way we created the quadrilateral MLON. In quadrilateral MLON, we join points M and N together, we join points L and O together. In this way we created two right triangles. The right green triangle MLO, and the orange green triangle L and O. So the area of the green right triangle LMO, it is equal to the base of the triangle, that is B, times the height to the base, that is A, over 2. Likewise, the area of the orange right triangle LNO equals to the base of the triangle, that is A, times the height to the base, that is B, over 2. So in total, the sum of the areas of the two triangles is equal to A times B over 2 plus A times B over 2. That is to say, it is equal to 2 times A times B over 2. We have 2 in the numerator and 2 in the denominator. So in conclusion, we found out that the sum of the areas of the two triangles, it is equal to A times B. So now we have to subtract from the area of the two sectors the sum of the areas of the two triangles, that is AB. So we subtracted from the sum of the areas of the two sectors the sum of the areas of the two triangles, that is AB. Okay, we got to this formula for the area of the length. Okay, then we took the common factor of theta from this formula. Here we took theta as a common factor. Inside the brackets we have a squared minus b squared plus pi b squared over 2 minus ab. Now we have to find out the value of theta, because we want a formula that the only missing variables in the formula will be the radii of the two shapes. So we find out the value of theta here. In order to find out the value of theta, we draw here the right triangle OML that we copied from the original drawing. In the right triangle OML, we know the triangle theta equals to ML over MO, ML equals to B, or MO equals to A, so in conclusion found out that triangle theta equals to B over A. So we know that triangle theta equals to B over A, but we don't want the value of, don't want triangle theta, but we want the value of theta itself. So in order to get the value of theta itself, we operated the opposite function of tangents on the result, that is B over A, and in this way we get the value of theta itself. So theta itself equals to tangents minus 1, that is the opposite function of tangents. We operated it on the result, that is B over A, and this way we got the value of theta itself. So theta itself equals to tangents minus 1 of B over A. Now we can substitute theta by tangents minus 1 of B over A. We did it, and we got that the area, the general formula for the area of any length, it is equals to A squared minus B squared times tangents minus 1 of B over A plus pi B squared over 2 minus AB. So here you can see that the only missing variable that we have here is A and B, that is the radii of the two shapes that intersect with each other. Now we can use this formula in order to find out the area of the big length and the area of the blue length, and then we subtract the area of the blue length from the area of the big length, and this way we get the area of the orange shape. So what is the area of the big length? Here actually the big length, it is actually was created by the intersection of the quarter circle, this quarter circle with this semicircle. By the intersection of the quarter circle with the semicircle, we created common area, and this common area is defined as the big length. Okay, so therefore the only thing that we have to know is to know what is the radius of the quarter circle and what is the radius of the semicircle. The radius of the quarter circle is 10. You can see that the radius of the quarter circle is 10, while the radius of the semicircle is 10 over 2, because the diameter is 10, therefore the radius is 10 over 2, that is 5. Okay, so we found out that A equals to 10 units is the radius of the quarter circle, B equals to 5 units, it is the radius of the semicircle. So the area, we put the data inside this formula and found out the area of the big length. The area of the big length equals to a square minus b square. A is 10 and b is 5. So a square is 10 square minus 5 square. B square is 5 square times tangents minus 1 of b over a. B is 5 and a is 10, so 5 over 10 is 1 half. 1 half is 0.5 times pi b square over 2. Okay, b is 5, so b square is 5 squared, that is 25, so it is 25 over 2 minus ab. A is 10 and b is 5, so it is minus 10 times 5. Then here 10 squared is 100 and 5 squared is 25. 100 minus 25 is 75. So in conclusion, the area of the big lens equals to 75 times tangents 1 times plus 1 of 0.5 plus, here we have 25 over 2 is 12.5 pi, 12.5. So this expression in total equals to 12.5 pi, and minus 10 times 5 is minus 50. So in conclusion, the area of the big lens equals to 75 times tangents minus 1 of 0.5 plus 12.5 pi minus 50. Okay? So, in the next step, we found out the area of the big lens, the area of the blue lens, the area of this blue lens. The blue lens is created by the intersection of the two semicircles with each other. The common area is defined as the blue lens. So we know that the radius of each semicircle it is equal to 5 units, so A equals to B equals to 5. And there we put the value of A and B inside the general formula and found out the area of the blue lens. The area of the blue lens is equal to A square minus B square, so it is 5 square minus 5 square, that is 0, times tangents B over A is 5 over 5, that is 1. So this expression equals to 0, plus pi b square over 2. B is 5, so b square is 5 squared, that is 25. So it is pi times 25 over 2 minus a times b. A is 5, b is 5, so 5 times 5 is 25. So this expression equals to 0. So in conclusion, we found out that the area of the blue lens equals to 25 pi over 2 minus 25. But 25 over 2 is 12.5. So in total, this expression equals to 12.5 pi minus 25. So in conclusion, we found out that the area of the blue lens equals to 12.5 pi minus 25. Now we have to subtract the area of the blue lens from the area of the big lens. In this way we find out the area of the orange shape. Okay, so the area of this orange shape equals to the area of the blue lens minus the area of the big lens minus the area of the blue lens. Again, the area of the big lens minus the area of the blue lens will give us the area of the orange shape. Okay, the area of the blue lens, the area of the big lens equals to 75 times tangents minus 1 of 0.5 plus 12.5 pi minus 50. And we subtract this from the area of the big lens, the area of the blue lens, that is 12.5 pi minus 25. So we subtracted the two expressions from each other and found out finally that the area of the orange shape equals to here we add, actually 75 tangents minus 1 of 0.5 plus 12.5 pi minus 50 minus 12.5 pi, so 12.5 pi minus 12.5 pi is 0 plus 25. So 25 minus 50 is minus 25, so in conclusion the area of the orange shape equals to 75 times tangents minus 1 of 0.5 minus 25. We found out that the value of tangents minus 1 of 0.5 is 0.46. We have to multiply it by 75, and we multiply it by 75, we got that it is equal to 34.77, and we have to subtract from it 25. In this way we got the area of the orange shape, the area of this orange shape equals to 9.77 square units. We finished with the first method. Then I presented to you the second method. In the second method, we actually calculated the area of the big lens directly. Then we calculated the area of the blue lens. Then we subtracted one from each other. In this way we got the orange area, the area of the orange shape DPQ. Again, the idea is to calculate directly the area of the big lens, and then to calculate the area of the blue lens, and to subtract one from each other. In this way we get the area of this orange shape DPQ. So actually in the first step we calculated the area of the blue lens. Now the blue lens was created by the intersection of the two semicircles with each other. In this way the common area is defined as the area of the blue lens. So we actually divided this lens, the blue lens, by the straight line NM. So this shape is the mirror image of this shape. So we can find out the area of this green circular segment, the upper circular segment of the lens. We'll multiply it by 2, and this way we'll get the area of this blue lens. Okay, so here what is the area of this circular segment MN? The area of circular segment MN will be equal to the area of segment MON minus the area of triangle MON. We know actually that the radius of each semicircle equals to 5 units. Okay, so the area of sector MON equals to the area of the circle over 4. Why? Because sector MON is a quarter circle, and the area of any quarter circle equals to the area of the circle over 4. The area of this circle with radius 5 is pi r square, and r equals to 5, so it is pi 5 square. And if we divide the area of the circle by 4, we get the area of this quarter circle. So the area of this quarter circle equals to pi times 5 squared, that is 25 over 4, so it is 25 pi over 4, minus the area of this right triangle, that is equal to 5 times 5 over 2, that is the base times the I to the base over 2. That is 5 times 5 over 2. Then we multiplied the area of this circular segment by 2. In this way we got the area of the blue lens, because those two circular segments are identical. The one is the mirror image of the other, so if we multiply 1 by 2, we get the area of the two circular segments that is equal to the area of the blue lens. So 2 times the area of this circular segment MN will give us the area of the blue lens. So the area of the blue lens equals to 2 times of this expression, and 2 times of this expression here, 2 times, we have 2 in the numerator and 2 in the denominator, so 2 will get cancelled. We left only with 25 here, and here we have 2 times 25 pi over 4. We divide both the numerator and the denominator by 2, and we get that 2 over 2 is 1, so 2 will get cancelled. In the denominator we have 4, so 4 over 2 is 2. So in conclusion, this expression equals to 25 pi over 2. 25 over 2 is 12.5, so in conclusion this expression equals to 12.5 pi, and in conclusion the area of the blue lens equals to 12.5 pi minus 25 square units. So we finished with the blue lens. In the next step we'll find out the area of the big lens. So what is the area of the big lens? The area of this big lens, the big lens was created by the intersection of this quarter circle with this semicircle. So I do the two shapes here. Here the intersection of the quarter circle with the semicircle will give us the area of this blue lens and the area of this big lens. We know that the radius of the quarter circle equals to 10 units. So this is 10, this is 10. While the radius of the semicircle is 5, so this is 5, this is 5. And here the radius OL of the quarter circle, it is known to the point of tendency, that is to say it is known to point L, that is the point of tangency of tangent ML with this quarter circle, and whenever we have a radius that is known to the point of tendency, then tangent ML will be perpendicular to the radius LO. So if ML is perpendicular to LO, it means that this angle equals 90 degrees. Okay? Then we have also here the radius MN is known to the point of tendency, that is to say it is known to point N, that is the point of tendency of tangent ON with this semicircle. And whenever a radius that is known to the point of tendency, then tangent ON will be perpendicular to the radius NM. So if ON is perpendicular to NM, it means that this angle equals 90 degrees. So actually, those two right triangles can go into each other according to side rule. Those two sides are both equal to 10 units, therefore they are equal to each other. Those two sides are both equal to 5 units, therefore they are equal to each other. And we have side MO that is a common side, it belongs to both triangles, so those two triangles can go into each other according to side rule. From the fact that those two triangles can go into each other, we derive that those two angles must be also equal to each other. So if this angle equals to theta, then this angle must be also equal to theta. Okay? So what is the area of the green circular segment? The area of the green circular segment will be equal to the area of sector NOL minus the area of triangle NOL. Okay, the area of sector, the green sector equals to the area of sector NOL minus the area of triangle NOL. We have already found out that the angle between the legs of sector NOL is equal to 2 theta, and the angle between the two sides is equal to 2 theta. Therefore, the area of sector NOL will be equal to the area of the circle, that is pi r square, and r equals to 10, so it is pi 10 square, times the ratio between the angle between the legs of the sector NOL over 360 degrees, or in terms of radians is 2 pi. So we have 2 in the numerator and 2 in the numerator, so 2 will get cancelled. We have pi in the numerator and pi in the denominator, so pi also will get cancelled. So in conclusion, we found out that the area of sector LON equals to 10 squared times theta. 10 squared is 100, so the area of sector LON, in conclusion, it is equal to 100 times theta minus the area of triangle LON. What is the area of triangle LON? The area of triangle LON equals to the multiplication of the two sides together by the times sinus the angle between the two sides over 2. So it is 10 times 10 times sinus theta, that is the angle between the two sides over 2. Okay? So the area of the upper circular segment LN equals to 100 times theta, and here we have 10 times 10 is 100, and 100 over 2 is 50. So in conclusion, this expression equals to 50 times sinus 2 theta. The area of this, the upper circular segment of the big lens equals to 100 times theta minus 50 times sinus 2 theta. Okay, our mission is to find out the area of theta and the value of theta, and also the value of sinus 2 theta. In order to find out the value of theta and the value of sinus 2 theta, I drew the right triangle LOM. In the right triangle LOM, LM equals to 5, LO equals to 10. In this right triangle LOM, triangle theta equals to LM over LO, LM over LO. So LM equals to 5 and LO equals to 10. So triangle theta equals to 5 over 10. 5 over 10 is 1 half is 0.5. So in conclusion, we found out that triangle theta equals to 0.5, but we don't need the value of triangle theta, but the value of theta itself. How we can get the value of theta itself? If we operate the opposite function of tangents of the result, we get the value of theta itself. So we operated the opposite function of theta of the result, that is 0.5, and we got the value of theta itself. So in conclusion, theta equals to tangents minus 1, that is the opposite function of tangents, or on 0.5. Okay? So we found the value of theta. In the next step, we actually found the value of sinus 2 theta. Sinus 2 theta equals to 2 sinus theta cosine theta. And here I drew the right triangle NOM here also. Again, our mission now is to find out the hypotenuse LOM according to the Pythagoras theorem. In the right triangle LOM, MO square equals to LM square plus LO square. MO square equals to LO square. LO is 10, so LO square is 10 squared, that is 100, plus LM square. LM is 5, so LM square is 5 squared, that is 25. So in conclusion, MO square equals to 100 plus 25. 100 plus 25 is 125. Now we took a root out of this equation, and we got that the value of the hypotenuse MO equals to the square root of 125. But 125 equals to 25 times 5, so we substitute 125 by 25 times 5. We took out from this expression, the square root of 25 is 5. Inside the root we left only with with 5. So in conclusion, the hypotenuse MO equals to 5 times square root of 5. Now, we found out the value of sinus 2 theta. Sinus 2 theta equals to 2 times sinus theta. What is the value of sinus theta? According to this triangle, sinus theta equals to Lm over Mo. Lm equals to 5. Mo equals to 5 over square root of 5. So, in conclusion, sinus theta equals to 5 over square root of 5 times cosine theta. Cosine theta equals to Lo over Mo. Lo equals to 10 and Mo equals to 5 over 5 times square root of 5. So in conclusion, cosine theta equals to 10 over 5 times square root of 5. So here we have 5 in the numerator and 5 in the denominator, so 5 will get cancelled. So in the numerator we have 2 times 10, and in the denominator we have square root of 5 times square root of 5 is 5 times 5. And then 10 over 5 is 2, so in the numerator we have 2 times 2, and the denominator we left only with 5. So 2 times 2 is 4 over 5. So in the denominator we have 5. So in conclusion, we found out that sinus 2 theta equals to 4/5. Okay, so in conclusion, we found that the theta itself equals to tangent minus 1 of 0.5, while sinus 2 theta equals to 4/5. Now we found out that the area of the lower circular segment Lm is equals to 100 times theta minus 50 times sinus 2 theta. We will substitute the value of theta by tangent minus 1 of 0.5, and we will substitute the value of sinus 2 theta by 4/5. We did it, and we got that the area of this circular segment, the upper circular segment of the big lens, equals to 100 times theta, and theta equals to tangent minus 1 of 0.5 minus 50 times sinus 2 theta, but sinus 2 theta equals to 4/5, so we substitute sinus 2 theta by 4/5. So in conclusion, we found out that the area of this circular segment, the upper circular segment of the big lens, equals to 100 times tangent minus theta of 0.5, and here we have 50 over 5 is 10, and 10 times 4 is 40. So in conclusion, the area of the upper circular segment of the big lens equals to 100 times tangent minus 1 of 0.5 minus 40. In the next step, we found out the area of the lower circular segment, the area of this lower circular segment. So here we actually used this, all the fields that we already found out by finding this circular segment. We know that Ml equals to 5, Mn equals to 5, No equals to 5, and Lo also equals to 5. This angle equals to theta, this angle equals to theta. So if this angle equals to theta and this angle equals to 90 degrees, then this angle must be equal to pi over 2 minus theta, and this angle also will be equal to pi over 2 minus theta for the same reason. Then we added the two angles together, and this way we found out the size of angle LMN. The size of angle LMN equals to pi over 2 minus theta plus pi over 2 minus theta. Pi over 2 plus minus 2 plus pi over 2 is pi, and minus theta plus minus theta is minus 2 theta. So in conclusion, we found out that the angle LMN, that is the angle between the length of sector LMN, it is equal to pi minus 2 theta. Okay, so here our mission was to find out the area of the lower circular segment of the big lens. So the area of the lower circular segment of the big lens will be equal to the area of sector LON, the area of sector LMN, the area of this sector, minus the area of triangle LMN. The area of the sector LMN minus the area of triangle LMN give us exactly the area of the lower circular segment LN. Okay, again, the area of the lower circular segment LN will be equal to the area of sector LMN minus the area of triangle LMN. So the area of sector LMN will be equal to the area of the circle that is pi r squared, r equals to 5, so it is pi times 5 squared, that is 5 squared is 25, so it is 25 pi, it is the area of the circle, times the angle between the legs over 360 degrees, or 2 pi. Okay? Pi minus 2 theta is the angle between the legs of the sector over 2 pi. We have pi in the numerator and pi in the denominator, so pi will get cancelled. Then open the brackets here, and you got here 25 pi over 2 minus 2 theta times minus 2 theta over 2 times 25. Okay, so here 25 over 2 is 12.5, so in conclusion, in total this expression equals to 12.5 pi. Here we have 2 in the numerator and 2 in the denominator, so 2 will get cancelled. So it is, this expression in total equals to 25 pi minus the area of triangle L or LMN, that is equal to 5 times 5 times sinus pi minus 2 theta over 2. So here, in total, in conclusion, the area of the lower circular segment equals to 12.5 pi minus 25 pi. And here we have 5 times 5 is 25. So it is 25 over 2. And sinus pi minus 2 theta is sinus 2 theta. Okay. So in conclusion, the area of the lower circular segment LN, it is equals to 25 pi, 12.5 pi, minus 25 theta, minus 25 over 2, and we substitute sinus 2 theta by 4/5. So in conclusion, we found out that the area of the lower circular segment of the big lens equals to 12.5 pi, minus 25 theta, but theta equals to tan x minus 1 of 0.5, so we substitute the theta by tan x minus 1 of 0.5, and here we have 25 over 5 is 10, and 10 times 25 over 5 is 5, and 5 times 4 is 20, and 20 over 2 is 10. So in conclusion, the area of the lower circular segment LM of the big lens equals to 12.5 pi minus 25 times tan theta minus 1 of 0.5 minus 10. And we have already found out that the upper circular segment of the big lens equals to 100 times tan minus 1 of 0.5 minus 40. So the area of the big lens equals to the area of the upper circular segment plus the area of the lower circular segment. Okay, so it is equal to this expression. And here we have 100 times tan x minus 1 of 0.5 minus 25 tan x minus 1 of 0.25 is 75 tan x minus 1 of 0.5. Okay, it's 70 times tan x minus 1 of 0.5. And we have minus 40 minus 10 is minus 50. And we left only with 12.5 pi. So the area of the big lens equals to 75 times 10 minus 1 of 0.5 minus 50 plus 12.5 pi. Okay, so the area, we have already found out that the area of the blue lens equals to 12.5 pi minus 25. So we subtracted the orange shape equals to the area of the big lens minus the area of the blue lens. So we subtracted the two expressions from each other. The area of the orange shape equals to the area of the big lens, that is 75 times 10 minus 1 of 0.5 minus 50 plus 12.5 pi minus the area of the big lens, that is equals to 12.5 pi minus 25. Okay, so we have 12.5 pi minus 12.5 pi is 0, and 25 minus 50 is minus 25. So in conclusion, the area of the orange shape equals to 75 times 10 minus 1 of 0.5 minus 25. We know that 10 minus 1 of 0.5 is 0.46, and we multiply it by 75, we get that it is equal to 34.77 minus 25. That is the area of the orange shape. That is to say, the area of the orange shape equals to 9.77 square units. Okay, so in conclusion, we found out that in both methods, the area of the orange shape equals the area of the orange shape equals to 9.77 square units. Okay, thank you very much.